In this unit, we're going to be talking about applications of integration. Specifically on this lesson, we're going to be talking about some velocity and net change. So we've talked about a little bit of this before, but we're going to do a quick review that we're going to be talking about position, velocity, displacement, and distance. So a position could be related to a height of an object from a certain point or left and right from kind of a distance in either direction. So it could be positive, could be negative. Velocity, if we're talking about functions, the velocity is the derivative of the position function, right? And then acceleration, which is not on here, would be the derivative of the velocity function. We'll also talk about displacement. Displacement is us finding the area under a curve. And we're going to be, displacement refers to net area. So positive areas are treated as positive areas, negative areas are treated as negative areas. We'll add the two together and see what happens. Versus distance traveled, which is a total area, where area is treated as area. So if it's a negative area, it's just treated as area. Positive area is treated as area. And we'll add all those values together. Okay, so that one's going to typically take a little bit more work because you got to figure out if you have a function versus a graph. You have an equation, you kind of need to create a graph and figure out where are positive areas, where a negative area is going to happen. This won't consider that at all. And so you'll have to do a little bit more work to kind of separate out positive areas and negative areas. So if we're talking about, so let's kind of get into this here a little bit, that if we do the antiderivative of a velocity function, that's going to give us a position function, right? So a velocity function is really the derivative of the position function. And so when we do the antiderivative and we're finding the area under the curve, we'll do the antiderivative and then plug in our bounds and find the difference between them. And so this gives displacement, which is a change in position of an object from A to a B. And remember that displacement is a net area, right? So it's the area under the velocity curve. So this should not be confused with the distance traveled over a time interval, which is the total distance. That would be different. We would really need to separate out some positives and negatives on this. So for example, it says, consider the graph shown in the figure, which gives the velocity of an object moving along a line. Assume time is measured in hours and distance is measured in miles. So we have this positive velocity transitioning to negative velocity, transitioning to positive velocity, and these values are representing the areas under each of the sections. So on what intervals is the object moving in the positive direction? Positive direction is going to be represented with positive values. So from 0 to 1, all right, we'll include 0 because at that moment it had positive velocity. But then at 1, we have 0 velocity, so we will not include this. And then from 3 to 5, we have positive y values, which are going to represent positive velocities. So we're going to go from 3 to 5 and not include those because at 3 and at 5, we have 0 velocity. And so it's not a positive velocity. We're moving in a positive direction. So what is the displacement of the object over the interval 0 to 3? So if we're talking displacement, right, we're talking net area. So positive area is positive area, negative area is negative area. So if we're going from 0 to 3, we have an area of 12. And we have an area of negative 16. And if we add those two together, we have more negative area than we have positive area. So our final answer will be negative 4. And let's throw a label onto this because we are talking about an object moving along a line. So we're kind of moving left and right. And we're talking in miles. So that would be a negative 4 miles would be the displacement, which would mean we would have gone to the right 12 miles and then back 16 miles to the left. And so we would be more left than we would be where we started. What is the total distance? Right, that's different. So total distance is from 1 to 5. We have a negative 16, but we're going to treat it as area plus 10. And so our total distance was we went 16 in one direction, 10 in the other direction. So we really want a total distance of 26 miles. But where we ended up, again, if we were doing just displacement or net area, we would have ended up further left than we were right. And then what's the displacement of the object over the interval from 0 to 5? So not total distance, we're talking displacement. So positive areas, negative areas, negative areas. So 0 to 5, we're going to be adding 12. plus a negative 16 plus a 10. So that's a 22 minus 16 would give us a total of 6. Right? And then describe the position of the object relative to its initial position after 5 hours. So this is that kind of answer of we started off and we went 12 miles to the right. And then from here, we went 16 miles back because we had a negative velocity, so a negative direction. And then from here, we went 10 miles back to the right. And so where would we end up? And that would be what we just did right here. So 12 plus the negative 16 plus the 10, we would have ended up 6 miles to the right of the initial that's right, initial position. Right. So if we would have had a negative in the end of that, we would have been further to the left from the initial position. All right, let's do one more example. So this is, we're going to find from this graph. So this graph, we're going to try to find this displacement, these areas under the curves from 0 to 5. We're going to find the distance traveled, and we're going to find the position at 5. So they don't give us the areas, but they give us these triangles that we can figure out the areas. So this right here is a 2 by 2. So we're going to figure out some areas. We're going to do 1/2 2 times 2. So 4 divided by 2 is an area of 2. And then this thing, it's kind of hard to tell of what that width is. The height is 1. So we have a 1/2. The height is 1. And the base is tricky, but we're going to figure out the slope to this. So if we go from a negative 1 up 1, 2, 3 over 1, that means each one of these things is going up 1 over a third, up 1 over a third, up 1 over a third. So that point is 1, 2, 3, and 1/3 for that point right there. So our width is 1 1/3. Let's call that 4/3. So then when we do our area, we're doing that 2 can simplify with the 4. So we're looking at the area is 2/3. And we're going negative. So it's a negative 2/3 for that area. And then this one is 1 2/3. So 1/2, 1 2/3 is 5/3 times a height of 2. And 2 and the 1/2 cancel. So you have an area of 5/3. All right, so we got our stuff. To find our displacement, we're just going to add all those pieces together. Positives are positive, negatives are negatives. So plus a negative 2/3 plus a 5/3. So if I put my fraction pieces together, we're going to have a 5/3 minus a 2/3, which is 3/3. So 2 plus the 3/3, that's really just a 1. 2 plus 1 is an area of 3. Our total distance traveled is now going to treat everything as a positive. So we'll be adding the 2/3 rather than subtracting it. So we're looking at 2 plus 7/3. So that, if I put that over 1, that's going to be a 6/3 plus 7/3 equaling 13/3, or 3 goes into 13 4 times with 1 left over. So that's our total displacement. So we moved right in a direction, we moved left, and then we moved right. So that total right, left, and then right would be a total distance of that. But we would have started, and that's what this question is, what's the position at time equals 5? Well, our displacement was we did go right, we did go left, and we did go right because of the positives and negatives. Where are we? So assuming assuming we started at 0, whatever that original distance was, at the origin or whatever you want to call it. So assuming we started at 0, then we are now at 3. Right, if we started at 5, then we're now at 8. We started at -2, we're now at 1. Just depends on wherever you started. And since we don't know, doesn't give us any information about it, we'll just assume that we started at 0. All right, so those were a couple different examples talking about the difference between displacement, net area versus distance, which is total distance. Positives treated as positives, negatives treated as negatives, versus everything is just treated as positive.